Hello, today we are going to talk about KDE tests, also known as unit test, as xunit, qtest lib, qtest, make test, ctest. Okay, so let's start from the beginning. I have kdesrc-build for the version 5 of KDE Frameworks 5 and Qt 5 setup. I have just built the KDE Git repository calendar, which is this one. The Git repository is https://invent.kde.org/pim/calendar. It built 94 Git repositories, and then the 95th one was this one, the calendar. Okay, the command line was simple: kdesrc-build space calendar, which builds all of the dependencies, and for each of the dependencies and the calendar Git repository, it runs Git operations to make sure that the correct branch is used in the local Git clone, in the Git working directory, and then it's running CMake configure, then make -J16 in my case, so because I have 16 CPU threads, and then it runs make install. But in addition to these steps of Git, CMake configure, make, which compiles, and make install, which installs in ~kd/usr, kdesrc-build has an extra option, which is the option to run tests, which is called --run -tests. So in order to find out this, I went to the kdesrc-build git clone directory, and I started Visual Studio Code there, so code space and then dot, which means open the current directory, which is ~kd/src/kdesrc-build directory in Visual Studio Code. And then I went search for test, and I need to ignore all of the files that end with include. I need to ignore the string latest, so I'm searching in substrings and case insensitively. Okay, and at some time I bumped into this one, so run tests, which is a default global flag. So most of the kdesrc-build command line options can also be configured in the configuration file. So I'm looking for anything that contains test and can be passed via the command line or via kdesrc-build or configuration files. So I found run tests. I also found no tests. So no tests is the negation of run tests. Okay, so let's see how that thing works. So the next step would be to search for the word tests with match case. And in here I find documentation, so for the no tests option, and for the run tests option. So let's see how kdesrc-build works if we tell it to run the tests. I don't want kdesrc-build to do anything on other KDE Git repositories except calendar, so that's why I'm using -no -include dependencies. Then I run -tests. The output is this one, so identical to what happens if we go kdesrc-build calendar. So it says building calendar from KDE, fetching, which is a Git operation. We didn't say -no -src, so it does Git operations. Okay, then it says CMake targeting Unix make files. This is the CMake configure step. Then this is the make -j16 step. And then this is the make test step. And only then it runs the final step, which is make install. So by default, if you do not pass run tests, it will skip these lines. So from compiling, it will jump straight to installing. Okay. Let's see if we can have more detailed output, because just 2 lines for running tests is too little. So we go -debug. This is the make, the compiling step. And after that, it should run tests. So says running test suite. Said non-zero exit status, which is an error, which means that running test has failed. 2 tests failed for calendar, and it gives me the file where kdesrc-build has saved the logs. So let's look at this. Ctrl-Shift-C. Okay, Ctrl-Shift-V, and then the end character. Okay. What does it say? That a Conadi SQLite incidence occurrence model test has failed, and a Conadi SQLite to-do sort filter proxy model test failed. Okay, then we see the keyword ctest. Okay, so let's prepare a bit of a text file. So we're at the following steps. We went kdesrc-build calendar. Then we went this thing. This has run the tests using kdesrc-build. Then we see that what kdesrc-build actually does is start a child process with this command line. Okay, so gmake space test. So command line with just 2 strings, gmake and test. This is an array. Okay, let's see if this is if we run gmake test, we get the same output as this one. No, this one. Okay, Ctrl-C, Ctrl-Shift-V. It says that no rule to make target test stop. Why is that? Because we're in the wrong directory. It says it's running gmake test, but from the build directory. So let's go there. Okay, this thing. Ctrl-C, CD, Ctrl-Shift-V. And now we can run gmake test. The output that comes via standard output and standard error from the process CMake test should be the same as what we see in this file. So it says running test, so this is where the output starts. Test project, 15 out of 15, 85% total, failed test 14, errors output use CMake. Okay, so this is the standard output plus standard error combined of this command line. Run from this directory. Okay, next, what it says errors while running ctest. So what is ctest? Let's add it to our list of things. And then it says use rerun failed output on failure to rerun the failed cases verbosely. So let's see what this command line parameter is for. It might be either for ctest or for CMake test. So let's try for CMake test. Nope. Invalid command line parameters for CMake test. So it might be for ctest. What is ctest? There's a lowercase only ctest executable on my machine. There's no uppercase C, uppercase T, and then the rest lowercase est on my machine. So this thing is ctest. Okay, so we go ctest. So without any parameters, it returns the exact same standard output, standard error. So without the prefix running tests. So line 3 is from probably from CMake test, while starting from test, the output until this part, line 45, is from CMake, whereas line C from ctest and line 46 and line 1 are from the wrapper around ctest, which is CMake test. Okay. And then on the very last line, ctest says that you could run itself, so ctest, using these command line parameters. So let's see. Ctrl-Shift-V. Okay, so what it does, it says rerun failed, so ctest somehow knows how many tests there are. There are 15. Knows which ones are failed, which is 14 and 15. And now rerun failed means it will only run the tests that have failed, which is test 14 out of 15 and 15 out of 15. So it starts with the test 14 with the correct name, this guy, and says failed in 0.65 seconds. And it says could not find Dr. Conky, Cake Crash, started Akonadi Demon, SQLite 3 not loaded, all sorts of things. The problem is right now, from what I see, that the wrong executables are started because we didn't set the prefix. So let's set the prefix first and then we'll see if that's enough. So the prefix .sh file resides in tilde/kd/build and then / the name of the KDE Git repository, is named prefix.sh, and for all of the KDE Git repositories has the same content. It was created by the KDE Git repository extra CMake modules. So it prepends something to the path, prepends something to other 5 environment variables. So let's source first the prefix and then run ctest rerun failed. Okay, the tests still fail. Because I do not know why. Still, this is not a unit test because unit tests are not allowed to start sub-processes. This is a debug tool. So the fact that some so-called unit tests are way too large and touch the hard disk or exit the computer to go to the internet or call SQL database servers, that's totally not a unit test. A unit test tests a small part of one function or method inside of a class. That's what it does. It tests a code path inside of a method and should not have ugly dependencies, so should not read-write from the hard disk because files might be missing during the make test phase, or the product might not be installed, or Akonadi might not be available, or Akonadi might not be configured to read emails, might not have any IMAP accounts configured, etc. Okay, so this is called an ugly dependency, the fact that it starts Akonadi server, totally an ugly dependency. Should not be part of the test suite. The test suite should always succeed and not be flaky. Should be part of another set of tests, I know, which might be invoked using something like make space test space long or something. So another make file target, especially for the flaky tests. But the non-flaky ones should run fast and should work this and fail the same on all of the machines. If you run the same tests on 3 different machines and test 3 fails on the first machine, the test number 3 should fail on the other machines. So the way tests fail or succeed should be the same no matter the Linux operating system and the machine that we use. Okay, so with that out of the way, let's look at how these things are implemented. What is in fact upstream test? What is upstream test? We go to the build directory, so tilde/kd/build directory. We search for calendar, and in there we search for upstream test. Ctrl+C, Ctrl+V. Upstream test. I'm not sure where upstream test comes from, but I know that inside of the KDE tilde/kd/build/calendar/bin directory, many binary files, so executable files such as cryptotest and shared libraries such as libaconadi quick plugin so files are getting built. So cryptotest is in fact an executable. So starts with elf, can be run. Where are we? Control Shift D. Okay. Build calendar and then bin again. And let's look at the executables. So there's cryptotest, address model test. So the name of the test might be different from the name of the executable, I guess. Then there's attachment test, which is this guy. Then call util test, which is this one. A reminder model test, which is this one. Filter test, which is this one. So for many of these tests, 15 that ctest and make test know how to run, are backed by an executable, which exists in ~kdesrc-build/calendar/bin directory. Okay, to do sort filter is this one, and incidence occurrence is this one probably. Okay, then what is CMake? CMake is /usr/bin/CMake. Which is a symlink to the executable /usr/bin/make, and make is the GNU make utility. Okay, so back to this file, which we need to save. F71327. What was that? kdesrc-build. Okay, so CMake test is GNU make is make test. Okay, so it does not matter if you run the executable make or if you run the executable CMake, because CMake is just a symlink to make and it will do the same thing. Okay, so the make Unix command line searches in the current directory for a file, make file, and if it finds it, it will run the target which the command line CMake receives as a command line parameter. So the command line parameter of CMake is test. CMake will search for the makefile file, and if it finds it inside of the file, it will look for the make target named test. Let's search for that thing. So we're inside of the build calendar directory. In here there should be a make file, a file that's named makefile, no extension or anything, uppercase M. Okay, and this file should have a target which is called test. not tests, but test. Control C, Control V. Okay, so this is the target. The target is specified by the name of the target and then a colon. So on line 69, the make target test starts. There's sibling targets such as test/fast, which just calls the test make target. Okay, what does it do? As we saw, it says running tests, and then it runs usr bin ctest, force new ctest process, and then additional arguments that we pass. Okay. And then what else? Just that. It adds a line at the end, which is which one? Okay, that one last line. This line 46, CMake, colon, and then something. Okay, how does the make file get generated? It gets generated using the command line CMake with a long list of parameters. How we can find out that list of parameters? Well, we can do that. So we need to run kdesrc-build calendar, and then --no src --no include dependencies --refresh build, because we want it to force the CMake configure step. There's a command line parameter for kdesrc-build to force CMake configure. That's not named refresh build, but I'm not going to look for it. So kdesrc-build calendar no src no include dependencies refresh build --debug, and then that pipe thing, which I do not know by heart. Okay, kd.org, hamburger menu, get involved, development, and then not in here. This thing. Ctrl-Shift-V. Okay, so while this is running CMake -j16, which actually compiles the source code, we can already look at the file. So kate-a.txt. So what this command line does, it says run kdesrc-build, k calendar in our case. No src means do not do any git operations, no include dependencies, do not look at the other KDE git repositories, just calendar one. Refresh build means do everything from scratch, so CMake configure, a complete build, not a rebuild, not a incremental build. Do a make install, and then be as verbose as possible, --debug. Then I'm taking all of the standard output and standard error of this command line, and I'm putting into the file a.txt from my home directory. So now I'm opening the file a.txt from my home directory using the text editor Kate, and we're going to look for the CMake command line. I want whole word, not like that. Okay, so the first part of kdesrc-build is deciding what is the list of KDE Git repositories that need to be built before calendar. So this is what it does for most of the output in here. So still computing the Git dependencies. Okay. So the actual output that's not kdesrc-build deciding which KDE Git repositories need to be built first before calendar can be seen in the minimap, in the scroll bar, where this pattern ends, the pattern with gaps. Okay, so in here we can click and it will go there. Okay, so this is still deciding the KDE Git repository dependencies, and finally it starts building calendar on line 4682. The first thing that it does, it's after it done Git operations which happen in parallel with the rest of the build procedure. So that's why we do not see its output here, because it has already been done in parallel with deciding the list of dependencies. So it starts the operations for calendar, and the first one after Git operations is running CMake configure. So the command line is this one. This is the CMake command line, which creates the makefile file. It says -g, so what to generate Unix makefiles. So this is in fact the command line with a backspace to escape the space between the words Unix and makefiles. Okay, so this thing will look inside the git clone directory, inside of the git working directory. We'll look at all of the CMake list.txt files and compile a Unix makefile that's being saved into the current directory. So it says -b dot, and the current directory is this one. So it's a tilde/kd/build calendar. Okay, so in this directory, tilde/kd/build calendar will be generated a file named makefile with an uppercase M of type Unix makefiles, which has support for all of the things, for make test, for make install. Okay, so again, this is the tilde/kd/build/calendar directory. In here it generates the makefile, and the makefile knows how to run tests, but not only, it knows how to build and install. So there's an install target, there's an install/fast target. The install target calls CMake -p CMake install.cmake, which is this file. So the prefix is tilde/kd/usr. It writes a ton of messages. Then it does the org kd calendar svg. the appdata.xml, the desktop file, and other files, I don't know where from. Okay. The build phase is probably, I don't know, I know the name of it. Default target is all, which will run compilation and installation. This is the target all. There's a target clean for rebuilding, not building. So by default, when you go make will actually just compile the source code in an incremental way. So it does incremental build, not rebuild. For rebuild, you will need a way to delete all of the intermediate build artifacts, such as .a files, .so files, executables, etc. So that's why there's a clean make target. If there's a make install target, there's also a make uninstall target, which deletes files from ~kd/usr, whereas the install target copies files from here, here, etc., and puts them in the prefix directory, which is ~kd/usr directory. Okay, so calendar uses three directories: ~kd/src/calendar, the directory where the Git repository was git cloned. So this is the git working directory, and this is the .git hidden directory. Then another directory used for actually building calendar, which is ~kd/build/calendar. In here, CMake generates a ton of intermediate files and configuration files and make file and CMake install file, etc. In here, the make phase will build files, so this, etc. And then the make install phase will take the needed files from ~kd/build/calendar directory and put them in ~kd/usr directory. So binaries will put them here, calendar, in ~kd/usr/bin. Libraries will be put in ~kd/usr/lib, somewhere in here, I don't know where. Okay, there's other files. There's inside of the ~kd/share directory, desktop file, XML files, update, etc. SVG icons. Okay, so now we know how to run the test suite in various ways. So gmake install, make install, or ctest. And we know that the actual tests, so the 15 of them, are actually executables on the hard disk, or we could just run the executables on the hard disks or in order to run the tests. So we could go for crypto test /crypto test. So the bin directory is empty. Because it was deleted. Okay. Ctrl+Shift+T, back to where we were. cd build calendar and then bin. And then we're going to run just the one test, the crypto test. This one, /crypto test. Okay, so this is was run with a more verbose output. another way to run just this test is, let's see how it's done. So we could run the executable that contains the test, just one test. We could go delete the list of tests inside of the executable to run, because inside of the executable you might have more than one test. There's this one, test, decrypt, and verify its signature. So let's see how that works. Okay, so it has run just these parts. Okay, we'll see in the source code how test, decrypt, and verify CRLF encrypted with signature is actually implemented. What's the CPP file? What's the body of this method? So this is a method in this class. Okay, and then we can list functions. Okay, so this is probably just a class, crypto test, but it has 6 test methods: test, decrypt, decrypt and verify, etc. Okay, we can change the verbosity level, -v1, -v2. There's -vs for signals. There's -o to redirect to the output to a file. Okay, so we know how to run the tests. cd Ctrl-Shift, Ctrl-V, tilde/KDE, and then we can run individual tests like this, like this, like this. And then there's the other parameters for verbosity level, -v1, -v2. Okay. Next, once we know how to regenerate the make file that contains the instructions for make test using the long command line. Where is it? Okay, so this actually recreates the makefile file because we said refresh build, and this does kind of everything. Okay. As we saw, the makefile for the test target, it just delegates to the executable ctest. Okay. Let's give the wiki page for tests. And now let's see how the source code looks like. So the source code for tests, again, we saw that there are 15 executables. Each of these executables have CPP files, so source code files written in C++. And in order for them to be built, we're using the build framework CMake. So there's going to be a CMake list.txt file that defines these executables. Okay, for that I'm going to use the ID Integrated Development Environment Qt Creator. Okay, the procedure for Qt Creator is this one. Okay, so let's see how this thing works. I have installed it. I've installed Qt Creator from the Qt website to get the latest and greatest version. So Qt, this is qt.io. I have a screen recording on YouTube about how to install Qt from the Qt website. In kdesrc-build, I have set CMake options, the CMake build type debug in order to be able to debug. I've built calendar, and then I'm going to do these steps. So file, close all projects and editors is disabled because all of the projects and editors are already closed. File, open file project, we need the directory where we git cloned calendar, and in there should be a CMake list.txt file. So that's the src directory. Let's go there, src calendar. In there's a CMake lists file with an uppercase C. This one, CMake lists.txt. It says file, open file or project. Control V and then give it the CMake lists.txt file. Open. Then it says left sidebar switch to projects mode, which is this one, Control 5. This is the tooltip. Switch to projects mode, Control 5. Then says manage kits. Under kits manual, this guy. So this is the kits and then manual. There should be only the desktop default. The imported should be deleted. So I'll remove it. Apply. Okay. And now it has added a ton of extra kits that again I do not want. So manage kits again. Remove everything. I just keep the desktop default, apply, okay. And then it says button import existing build, which is this button. I should use the directory not tilde/kd/src/kcalc, but tilde/kd/build/kcalc. So let's do that. I replace src with a build. Choose. Okay. CMake was run correctly in here, and then let's go back. So escape, left sidebar, switch to projects mode. This is the thing, and then build and run. Build and run, yes. And then not a desktop kit, this guy imported kit. Build, and then build settings should be edit build configuration. In this combo box there should be the value debug2, which it is. Okay. Then we need to look at the prefix file and convert that to this syntax. So this syntax works for me, but I'm going to convert it anyway. So let's open the file, which is inside of the build directory. Okay, so let me What's in here? Kate /KDE build calendar prefix and then the end character. Okay, I have the prefix, and now I create a new file, Control N. I need a syntax like this. Out of the prefix. So how do I do that? Well, my username is this, and the KDE directory in my case is different, so I need to replace that. Control R, tab, Control V, plain text, replace all. And then I need to see the path environment variable is modified by prepending this to the environment variable path. The syntax inside of Qt Creator is path equals plus means prepend, not postpend, not append, this thing. Okay. Then LD library path is commented out, we'll ignore it. Then XDG data dirs, this thing is prepended to XDG data dirs, correct? Then XDG config dirs is prepended this thing, yes. And then this thing, we can see that it makes it yellow in online 4, so it's the same string. This is the same string, and then this is the same string. Okay, so I've converted the syntax of prefix.sh, which is a syntax for Bourne shell, for bash in this case, to syntax that's understood by Qt Creator IDE in here. So it says left sidebar switch to projects, Control S, build and run, not the desktop kit, import key. So this guy, we need to go to run, and then run settings. Where am I? Here. Run configuration, run configuration. In here I need to select one of the tests. We're going for crypto test because this is what we've studied previously. Run configuration, select kcalc. So I've selected as run configuration the crypto test. Then this is the CMake executable, so it creates an actual executable on the hard disk, and that's what we're going to run, and we're going to attach with the debugger too. Okay. ctest type binary executables. Environment use build environment. So environment use build environment. Press the details button. Press the reset button. So the reset button is disabled, I cannot press it. Then press the batch edit button. And in here I paste the text block that I prepared previously, this guy. I press OK. Next, on the left sidebar, there's the button run. The button above run, okay, this is the button run. Control R, the button above should say project calendar, kit imported kit, deploy configuration, debug 2, and then to run crypto test. Okay. First of all, let's make sure that the test runs. I'm pressing the run Control R button. Okay. Is the output the same? I don't know. So it says config, pass, warn, fail, actual, expected. These outputs seem really similar, but we're going to make extra sure. So let's copy the output from Qt Creator and use a GUI diff viewer. I use meld, I go file, compare, Control V, and then I'm going to put on the left hand side the output from Qt Creator, on the right hand side the output from the command line /cryptotest. And we can see that it's the same thing, which means that we've passed the environment variables correctly to this executable, or this executable does not need any other files from tilde/kd/usr such as SO files. Okay, close without saving. So we know how to run a single test inside of the debugger, but we do not want to run the test. We want to debug it in order to see what is the source code for the cryptotest test. Okay, for that we're going to switch to the edit mode Ctrl+2. We're going to click on this button, hide left sidebar Alt-0 to make the left sidebar appear. This sidebar starts with a combo box by default, or in my case the value is projects. You could switch to file system view. So this is the Git working directory for calendar with the hidden directories not shown. So the directory .git is not shown in here. And another view is projects view, which is actually the CMake tree. So this is the CMake configurations unified and shown as a tree view. It starts with the calendar master, so this is the name of the Git project, the Git repository, and the branch, Git branch that we're on. And then it tells us that there's a top level CMake list.txt file. Let's look at it. So it's tilde/kd/src/calendar. If we hover on top of the name of the file inside of this combo box, it's going to show us the full path. So tilde/kd/src/calendar/cmake list.txt file. F3. Okay, so this is in fact the file. This is the top level CMake list.txt. So you should learn the CMake build framework. And this one will then also include other CMake lists files, list.txt files. Okay, how does it do that? It says add subdirectory autotests, add subdirectory src. So inside of all of these subdirectories, it's going to search for another CMake list.txt file. So let's look at the src subdirectory. This guy has a top level CMake lists file. Okay, which it then includes other directories, such as the directory lib. Subdirectory lib also has a top level CMake list.txt file, which does not include any other subdirectories. Okay, so there's more than one CMake list.txt file. One is the top level, which is this one, and this top level one includes the rest. So Qt Creator combines all of the CMake lists.txt files into one thing, which is presented as a tree view here. Okay, so as we know, CMake lists.txt, the top level file, at the end of it says add subdirectory autotests. Let's go there, autotests, is a directory, and in here it's shown as a CMake subdirectory. So I can expand this thing. It's showing me that inside there's a top level CMake list.txt file, which is this file. Okay. Which does it include any other subdirectories? I don't see any. Okay. And then what does it include? It includes filter, test, and does it have any executables defined? Yes, it has the executable filter test. So just one executable is defined in here, the executable filter test. But we know there's more, there's incidence, occurrence, model test. This is also an executable that we saw in tilde/kd/build/calendar/build directory. And then to do sort filter proxy model test was another one. Okay. Enable testing. Okay, let's search for crypto in somewhere. Control S, crypto. Okay. So inside of the src directory, which is this guy, there's a mail tests crypto test, okay, which has a top level CMake list.txt file. So that's probably mail, src, mail, and then tests. And this is the one. Okay, so the structure of directories on the hard disk is represented in this projects view in Qt Creator, and the top level CMake list.txt files from that directory is presented under the directory. So here, here, here. So this is the directory, CMake list under it, directory, CMake list.txt file under it, etc. Okay, let's look at the CMake list.txt file for crypto test. Does it contain an executable? Yes. The executable is named crypto test. There's just one CPP file, which is the source code of this test, which is called cryptotest.cpp. This thing. Let's look at the source code, F3. So there's a string, another one. These are asserts. So xunit test frameworks have asserts. These asserts might be is string equal to, is string less than, does string include, does string list include this string, is integer less than another integer, is this boolean true, etc. If the assertion fails, so if the boolean is not true and you say assert that the boolean is true, then on that line the assert will fail, the rest of the line will not be executed in the test method, and the test method will be written to the standard output or standard error as a failed test method. Okay. Should we go over xunit? Probably so. What's the thing? Okay, so we start at the very beginning, which is the c2.com, which is the first wiki from the inventor of the wikis. So there's a testing framework, came back 1995. Testing framework was the name. It was a package for Smalltalk, renamed later as xunit, Smalltalk unit. There's a test case, a test suite, test result, mocking frameworks. Okay, and has been ported with a similar or a bit different architecture to many programming languages. And the pattern is called xunit. So there's JUnit for Java, xunit.net for .NET, mstest for .NET, sunit original one for Smalltalk, etc. Setup and teardown methods. Okay. We'll go over exactly how the xunit framework that we use, which is ctest, qtest, allows you to write tests. Okay. Let's add this to the text file. Okay, so we see how the executable crypto test is created. It's created inside CMake list.txt file in the full path tilde/kd/src/calendar/src/mail/tests. The source code resides in a single CPP file, which is called cryptotest.cpp. It uses the qtest xunit framework and follows the conventions of the qtest xunit framework. Okay, so you have documentation galore. You can search for, for qtest inside all of the KDE Git repositories, for instance. Where are you? In order to see the syntax, right? So there's a C++ type, which is a class, and then there's a C++ object. The C++ type could have a constructor, and then the method is the actual test case. So when this CPP file is compiled, one executable file is generated in the bin directory, which is called download feed icon job test probably, and that's going to be one test out of the 15. And then for each of these executables you might have any number of test methods inside, and you list them with the name of the executable space minus functions, and you can run just one test method like this. Okay, qverify is an assert. Okay, I can see in here, where are you? A constructor destructor. I can see qtest main, which is a macro which probably creates the main.cpp, so void main argc argv c exported function, which is the entry point to the executable cache policy test. Okay. So this is a test method, and this is the data for the test, which is defined in here. Okay, says tutorial 2, data-driven testing of a date class. We have the test, which is the test method test date test month, which fetches data from somewhere. Where does it fetch it from? From its twin method. So this method is called test month. There's a twin method with the same name, test month, but then with the suffix underscore data. This populates a data structure, and the test method actually fetches data from that data structure and then asserts. Okay, so this is called a data-driven test. Okay, this defines the data structure, and this fetches the data from the data structure. So we have the crypto test, which is a number of tests. The number is given by the test methods. So there's a test decrypt and verify, test decrypt and verify key missing. So all of these are test methods and are going to be tested independently. So other xunit tests instantiate this class, call the setup method of the class, or the constructor, or the static constructor. Then they call the method, then they call the tear down methods, the destructors, the static destructor. And then for the next test method, again, it instantiates the object from scratch, calls the setups, constructors, and then the method. And the method does an assert. So it's called 3A's. So AAA. The first one is arrange, act, and assert. Okay, so arrange usually is building the world, so calling the new on some objects. Then act is calling the method that we want to test, so that method under test. So new of class to test. This thing is the object of type class to test, and then it calls the method. And you store the result of this method, I know, a boolean, for instance. Okay. And assert is making sure that the result of this method, which should always be true, for instance, is true. So you go, I don't know, assert dot is true, and then this result. Arrange, act, assert. we can see the first assert, which is output should be equal to the expected output, and the expected output is a string, so const q byte array. The output is the variable, so this thing, which is the result of this method, the method under test. So output is an non-const ref, so a in-out parameter. The method under test has 3 parameters and returns a result. The parameters are some enum, crypto protocol. Then there's the input byte array, so the input string, and then the output byte array as a non-const ref. So this is a in-out variable parameter argument to this method, the last one. So output gets populated in the method that we want to test, and then we compare or assert that the string returned by the method is identical to a hard-coded string, so to a string that we have hard-coded inside of the test. Tests have many hard-coded strings, integers, magic strings, enums, etc. And it's okay if unit test source code violates the don't repeat yourself DRY does not respect DRY. Okay. What else? Since the method also returns something via the return type, not just via the third parameter, this thing, decrypt result, which is a const crypto decryption result, which is, I don't know what. It's a struct with recipients, error, result, which is an enum, and then so this is a type. This is a vector of recipient. So vector meaning a list in C++. Error, error, which is what? Another struct. So struct, instruct, instruct. And the result is an enum of this type. And recipients is another struct which has two members, a string and a boolean. Okay. So in order to assert all of the members of the returned type, which is a struct with other structs and arrays and everything, more than one assert line was written. So it makes sure that the list of recipients is 2, and then the 2 recipients are the ones that we know they should be. Okay, it's because we created the input string using this information that there's 2 recipients, that the key ID of the first recipient is this, and the key ID of the second recipient is this one. Okay, so this is the assert phase, the last A. This is the act phase. No. This is a static method, right? What's crypto? Crypto is just a namespace. Okay, so this is a namespace, and this is not a method but a free function. So a function, there's not much to arrange. The arrangement is the fact that this is a certain integer, a certain string which was this thing but then encrypted. So you take this input string, you encrypt it, you generate this output, and then you use this output string as the input for the decrypt method to test that the encryption-decryption loop is lossless. Okay, so the rest of the things that you want to know about test methods, you will find either by searching about xunit, about range, about AAA in test units, about test units, and then about qtest and the qtest namespace. So you will have these things in the CMake list.txt file in order to request qt5 test. And in general, you can look at the source code of the other KDE Git repositories to see how test methods are written. Okay, let's put a breakpoint here. So until now we have just run the test. Now we are going to start debugging of this test. Okay, so again, running works. We can see the application output here, which means that also the debugger will work if we have put the breakpoint in the correct place. And we have put the breakpoint in the correct place because we can see in here test decrypt. So it has called this method. Okay, so start debugging of startup project. Okay, let's delete these breakpoints which are from previous weeks. I selected them and then I press the delete key. Let's look at the debugger, how it looks like. So there's a list of breakpoints. So says line 34 of cryptotest.cpp in here. There's a breakpoint inside of the method cryptotest test decrypt. And this is the call stack, so starts with the main, which main is was created by this macro qtest GUI-less main, which actually creates a int main, int argc, char, double pointer argv, and then another macro, etc. So this thing expands to the driver that is needed in order to execute correctly the first test method. So we instantiate the class correctly and call the setup correctly and then call the method. Okay. So we have an input which is a q byte array which was not initialized yet. So we're going to initialize it. We're pressing the step over F10 button. F10. Now the value of the input is this thing. We can see it either by hovering on top of the variable or by using the locals tool window in here. This is the view as a char array, a 1 byte array, and this is the view as a string. Okay, q byte array will be the output, so it declares the variable but does not initialize it. And then we're going to enter the method decrypt, the free function decrypt inside of the namespace crypto. For that we need to not go from line 36 to line 39, but to actually step inside the CPP file for decrypt. So that's debug, step into F11. So now we're in a totally different file in crypto.cpp, and we were in cryptotest.cpp. So from cryptotest.cpp line 34, it jumped to crypto.cpp line 315. Okay. So this is the protocol. It says open PGP, the text to encrypt, to decrypt, and then out data.